All right, so today we're going to get into bond energies. This is another way of calculating delta H for a reaction. And what this is measuring the amount of energy that is used to break a bond, and then the amount of energy released to form bonds, because that will then give us a total energy for the reaction. So delta H equals the sum of the bonds broken minus the sum of the bonds formed. So bonds broken minus bonds formed. So the way that you do this is you look at a reaction and you first figure out what bonds are broken and what bonds are formed. Then you look up their energy, the bond energies for those particular bonds, and add them up. Now this equation is not balanced. So I need a 2 there to make my fluorines 2. So I need a 2 there for oxygen. Okay. So the way that I do this is I first draw out the Lewis structure, the skeleton structure for the Lewis. I don't really, in this case, I don't really care about the lone pairs as much because we're not worried about like the lone pairs. We're just worried about the bonds. So CF4 is going to look like this. Okay, and then we have 2 O2s, which O2 has a double bond. Then we have CO2, which also has 2 double bonds, and then we have 2 of the F2Os. It's going to look like this. Okay, so then what I look at is I look at which bonds have broken to form from here to form this, and which bonds have been formed. So it looks to me like basically all these bonds are broken because nothing over here the carbons are bonded to the fluorine, and the carbon over here is bonded to oxygen. The fluorines are bonded to oxygen. So what I do is I put X's on what bonds have broken. So those bonds have broken, those bonds have broken, and then I circle the ones that have formed. So this one formed, 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 this one formed. Okay, so there's 4 CF bonds that have broken, 2 O double bonds, 2 C double bond O, and then 4 FO bonds or OF bonds have formed. Okay. So now I'm going to look up on there. You'll be given a table of bond energies. I'm going to look up how much each of these are worth. So a CF bond is 485 kilojoules per mole. An O double bond O is 495. A C double bond O is 799 kilojoules per mole. And then an FO bond is 190 kilojoules per mole. So then, so these are my broken and these are my formed. So I do bonds broken minus bonds formed. So and then however many there are, I'm multiplying by that number. That kind of is obvious, hopefully. So 485 times 4 gives me 1940, plus 495 times 2 is 990. Okay, so that's my bonds broken. Then 799 times 2 would be 1598. And then 4 times 190, 760. So bonds broken minus bonds formed. So 1940 plus 940 2880 minus 1598 plus 760 be 2358. Okay, and then that's going to equal 522 kilojoules per mole. Okay. And so again, from this we can figure out, okay, this is a positive value, so this is endothermic, and then it would be not favored. So this process is endothermic and not favored because of the positive value for the delta H. Okay, so again, just to recap, you don't have to do this, but I think it makes it easier to figure out which bonds are broken, which bonds are formed. So draw out the Lewis structure, just a skeleton Lewis structure. Figure out which bonds have broken and which bonds have formed. I use X's and circles. You don't have to. You can do something else. Then count them up. Figure out what their bond energies are. Do your math, and then go from there to get your answer. All right? Hope this helps. Let me know if you have any questions.